All right, so we have just learned that all we have to do to minimize errors and maximize the probability of correctly rejecting HO, that is correctly detecting a treatment effect, is to increase effect size. So what is effect size? Now, I'm going to sound a little bit facetious here, but quite literally, effect size is the size of the effect in your experiment or study. All right. And so let's talk about an experiment first, or a quasi-experiment. If we are testing an independent variable, then the effect size is how much the independent variable, how much influence it has over the dependent variable. All right, so if you do an experiment and your IV affects the dV to a very large extent, then that will give you a large effect size. On the other hand, if your independent variable affects your dV but only very weakly, then the effect size is going to be small. All right, and then effect size could be described as how strong the relationship is between two or more variables. So in other words, if you're doing a descriptive study and you're looking at, for example, okay, this is not very creative, but let's look at the relationship between height and weight. Well, that relationship is pretty strong, and so we would say that the effect size is large. But if you're looking at the relationship, say, between, I don't know, how fast your fingernails grow and your score on a statistics test, well, there's probably a very weak relationship there. So the effect size would be very small. Okay, so that's why I say effect size is simply how big your effect is. In an experiment or a quasi-experiment, it's how much influence the IV has on the dV. If it's a descriptive study or just some part of your study where you're looking at relationship between variables, you're not manipulating them, you just want to know if they're related to one another, then the stronger the relationship is between them, the greater the effect size. All right? Now, again, what we like about effect size is that if we can find ways to increase effect size, we will have that win-win-win situation, okay? All right, now, a little bit more that you have to know about effect size before we can look at how to increase it and have that triple win situation. First of all, you need to know that there is a difference between absolute effect size and relative effect size. So we have two ways, therefore, of measuring effect size. All right. So if we look at the absolute effect size in an experiment or a quasi-experiment, we're literally just looking at how different the means are from each other. All right. So whether you have 2 means, 3 means, 4 means, if those means are very different from each other, then we have a large effect size. On the other hand, if the means are very close to one another in value, then we would say that the effect size is very small. All right. Now, this is a very good way of looking at effect size, only there is a problem here, and the problem is that when you calculate the effect size in your experiment, you can't compare it directly to the effect size that somebody else found in another experiment. All right, so even though you may be testing the same variables, let's say you're looking at the whether or not people who drink coffee live longer than people who don't drink coffee. Okay, so you've got coffee drinkers and non-coffee drinkers, and you're looking at their average lifespan, right? You can do the study in your lab and get a certain effect size, okay, certain difference between your means, and one of your friends could do the same study in their lab, and they'll find, means for longevity, and they'll calculate their effect size, but you can't compare your two effect sizes because everything about those distributions are different, right? They have, you found different means. Each distribution of scores will have its own set of variability. All right, the standard error of the mean is going to be different for your study compared to their study. So when you want to compare effect sizes between studies, you can't look at absolute effect size. You have to calculate something different. And that something different is called a relative effect size. It kind of is reminiscent of z-scores. Remember how we learned that if you've got raw scores from different distributions, you can't compare them directly if you want to know how big or small, how good or bad each raw score was relative to their distribution, right? So when we learned about raw scores, we said if you want to compare raw scores from different distributions, in other words, compare apples and oranges, you have to standardize the raw scores. You have to convert them to Z. Well, that's kind of what you're doing here when you calculate a relative effect size. So the formula is you look at the difference between your means, right, and you divide by the standard deviation of the scores in your study. Now, this is the basic layout of how we would calculate the effect size, the relative effect size. I'm not going to go into the specifics, but that's in essence what you're doing, okay? So you're looking at the difference among your means, how different they are, dividing by standard deviation of the scores. And when you do that in your study, you've calculated the relative effect size. And then your friend would do the same thing in his or her study. And now you can compare the two relative effect sizes because in essence, they've been standardized, all right? By taking your difference among your means, dividing by your standard deviation, and your friend doing the same thing, each one of them has been standardized so that you can now compare the two, all right? So generally speaking, this is the preferred way of calculating effect size in any experiment or study, okay? How about an example of effect size, just to make sure that you've understood the concept? So let's run two experiments. One is an experiment to compare Tylenol versus Advil, and we're going to look at, I don't know, headache pain, right? To see if Tylenol relieves headaches better than Advil or vice versa. That's study A, experiment A. In experiment B, we're going to compare Tylenol to my personal favorite, Demerol, all right? Okay, so in the first experiment, comparing Advil and Tylenol, you're probably not going to see a huge difference between the means, right? So both may decrease headache pain to a certain extent, but they're probably pretty comparable. So the mean pain reduction for the Advil group is going to be pretty close to the mean pain reduction for the Tylenol group. Now, if we're just looking at the difference between those two means, then we would say that the absolute effect size is probably going to be very small, right? Because we're not expecting to see a big difference between them. Now, remember, we're only looking at the means here, so we're looking at the absolute effect size, right? Now, what about experiment B? In experiment B, we're going to compare Tylenol to Demerol. Now, I don't know if you've ever had Demerol. I've only had it once, but oh my gosh. This is a very, very powerful pain reliever. I'll tell you that much, okay? Now, again, if we were to compare the two means, all right, in terms of the amount of pain they were able to alleviate, well, here, wouldn't you expect to see a huge difference between Tylenol and Demerol? And the answer, of course, is yes. It's off the charts. This might get rid of your pain a little bit. This is going to alleviate it. So when we expect these two means to be very far apart, then we say that the absolute effect size is very large, all right? Now, again, it's absolute because all we're doing is we're looking at the two means, all right? So what about the relative effect size? Now, I can't tell you if the relative effect size is going to be larger here or here because it depends on how variable your scores are, right? In this experiment, we're going to get a certain standard deviation of scores, right? We're going to measure that. We're going to measure the standard deviation of the scores in this experiment. And then what we're going to do is we're going to use those and we're going to take the difference between the means here, divide by standard deviation, the difference between the means here and divide by the standard deviation. And then we'll have two relative effect sizes and we're going to compare them. Okay, so it really does depend on the standard deviation as well as how different the means are. I'm still going to guess, though, that the relative effect size here is going to be much larger than it is here.